That we are from different part of the world. All of you are from different part of the world, and that's what we like a lot about, because on a one platform you have so many people at the same time from different part of the world. So if you want to see the global stuff, you want to see the humanity, I always say that come to the Cypher Analytica course, where you will see the people from all races, all part of the world. People from India, from Pakistan, Afghanistan, Nigeria, Sweden, Sri Lanka, Malaysia, Congo, Mexico, Bhutan. I mean, you just name it. I mean, it's not necessary that every time you will be have all country, but most of the time, at least 10, 15 countries at a time I've seen. So that's a beauty of our courses, where you learn globally, right? That's a beauty about our course. I always say these things, and I love it when you know that when you have a knowledge where the things which we need to share, and and the people from all part of the world learn with you. That's the best quality of the things. How many of you feeling excited about it, that I'm learning with the global community? How many of you? Just just press or just show me the thumbs up. See, that's the beauty about our program. That's a beauty about, we should feel proud that Cypher Analytica platform give us this opportunity. And I will create a WhatsApp group where we all can communicate to each other also. If, because in a communication you can talk to each other if you have a problem in learning, because it is not necessary that all five fingers are same. All five fingers are different, and every finger has their uniqueness. And somebody will learn R faster, or they may know from previous classes or maybe previous learnings. So they may be able to help you quickly to how to install the R, how to go for this problem, right? So somebody is good in something. So it's like a platform where you build the relationship also. You build a relationship which lasts long, right? Because the intention is very clear about Cypher Analytica. Our intention is not to make money. Our intention is to share. Very clear that we want to share. When you share anything, you feel happy. You feel proud, isn't it? How many of you have experienced that when you give somebody, you donate something, you feel happy that day more than any other things? You just give small things. Even you just give a small chocolate to your niece or maybe colleagues or your friend, or a small thing, you feel automatically you feel happy. So when you will share this knowledge, think that how happy you feel, how big happiness comes to you, isn't it? So that's why I keep telling all the people around, whoever participates. See, learning is one thing. You are learning here, no doubt about it, but share it also. If you're really liking it, if you like it, share with others that, okay, this time I have learned, you can also be part of this program. I have learned these things very nicely. And you don't have, I believe that that's how the law of karma works. When you do good for the society, automatically it comes to you. And the Cypher Analytica from last 9-10 months, from the day the lockdown started for the corona, we have given this course free. We have waived off all our tuition fees. All of you know about it, right? The tuition fees for this program is around, I think in Indian currency, it is around 18,000. In 18,000, if you convert around 250 to $60. So from that time, we are giving it free, because that's how our team decided. The things we have earned from the society, it's time to give. It's a time to stand by with the global society, because problem is not only for one person, it's a global crisis. So even a small help to the society will make some changes somewhere. Don't care how big difference it will make to the world, but I care that I feel happy. And I, when I say I, it's we in the sense Cypher Analytica, me, Dr. Parmar, and other team members of Cypher Analytica, we feel happy to share that. And that's what we are doing from last 9-10 months. We are not charging any fees. What we are charging, we are just charging a small fees in terms of operational cost, in the name of certificate, study material, or you can say video recording of the session. So that's a small amount, the peanuts we are charging just to run the operation, so that that it should be, the show should be keep running. That's why we charge. And not all the participants able to pay, because we understand that it's a financial crisis right now. Many people have lost their job. They are in a financial crisis, so we have to help right now. But those who can support, I will obviously say that I will say that do it, because your small amount of help will make others also that to participate, because this program as 9-10 months run on that money itself. So it run on that small amount, and that's why we are able to continue this 9-10 months. isn't it? So we even, I mean, that many times had happened that when you go for the higher I mean the advanced classes, there's a lots of people good from good background from different big companies, from different good designation. They also sponsored also for the people. See, there is a lots of sponsorship also come from them for few people. They know that this guy is very sincere about learning, so why not sponsor this guy? So they sponsor you also. So out of these 100 people, 90 people, you know that some everybody is watching each other. They know that who is sincere, who is not. But sometimes you are not able to pay for the high, because in higher classes we have make a compulsory that at least you pay a small amount, that one. Then you able to join that. But for part one and intermediate, it is free. Only few people who want to get the study material, certificate, and the video recording of session will pay and get a priority benefits, right? So that time these people will help you, right? So I'm just telling you in the why I'm telling you this, not because you pay, but if you are capable of paying, do that. It will help others also, some way around it will come back to you. Help this time to the society. I'm sure that all of you must be doing in some way or another way. I'm not talking about only this workshop. In some way or another way, you must be helping in the society. So if you are not doing, please do that. Do it in any way. The best thing is that sharing the knowledge. If you have some knowledge, share with kids. Give go to, you know, that some schools which is not able to afford right now. Teach the kids or do something, right? So that way you will be able to, you know, that make this world beautiful, make this world, you know, that a real global community. All of you agree with me or not? Do you think
Yes,
I'm
sir.
talking sense?
Yes, sir.
Thank you, thank you. So let's say that we are a global community. It's a global platform, Cypher Analytica. Once again, welcome you all and feel proud to be, you know, that become a part of this journey. You should feel proud. See, yesterday you have learned, you felt happy, you felt something that it is good for you. That's why you joined back today. So you can pet for yourself. So just right hand, just pet for yourself that I have given effort to come back today. Just do it, do it. You feel happy. Just do it. Right hand on your left shoulder, very small yoga. Just do that and feel happy. Keep us, you know, that good smile on your face. It makes beautiful world. See, that's how beauty about our this world. All right, very good. So I will welcome Dr. Parmar again. Sir, you there? Dr. Parmar, you there, sir? Okay, let him join. Meanwhile, maybe he's having tea, coffee right now. So, till meanwhile he join. If anyone has any concern regarding this workshop, please let me know. And I have one more information for you. Uh, if you have question, ask, or I'll go for that part. Okay. So looks like all of you are fine with that. So this workshop, whole workshop of R is divided into four parts: R1, R2, R3, and R4. Right? This four workshop. R1 we call it foundation program. R2 we call it intermediate program. From intermediate program, the workshop is 10 days. R1 is 1 week program. R2 is 2 weeks program. R3 and R4 is called advanced program. Advanced 1, advanced 2. So R3 is again 10 days program. R4 is again 10 days workshop. R1, R2 is open for all. It is open for all. Anybody can join and be part of this program. But lots of people sponsor it by, you know, that having as I said, that for the certificate, study material, and all. Until R2 you can do that, but from R3 it is paid program. Paid program in the sense, not the fees, only the certificate is very small amount. All right. So when time comes, we will tell you that also. So right now my focus is that you focus on R1 properly and learn it properly, because when it comes to R2, automatically, if you see that that the population will be reduced, not this 100 people will join, only let's say that 50 people will join in R2. Then in R3 again filter 25 people joins. Why? Because your specialization is going there in R3, R4. Then you are become specialized in R. So you become a data scientist in through R. So you go in that way. And we have divided this small part of the course so that you can repeat your course n number of times. You can revise it and should not feel bored in that learning for 3 months at a, in a one shot. So we have kept a small part. Many times it happens that people join from offices. I'm sure there's lots of participants here joining from the workplace. How many of you are joined here from workplace? Is anybody here who have joined from workplace? Can you just name it? Say hello.
Hello. Yesterday I joined from my office. I tried to be with you,
Yes.
and Alhamdulillah, I succeed in this aim. But already you sent the material today. Thank you very much for
Thank you.
this effort.
Who else has joined from the office?
I am doing home office, Mukesh.
Okay.
Still, like I'm joining from office and home office. Yes,
Okay.
we are not allowed to commute to the offices due to Corona restrictions.
Yeah, home office is the office itself. So you're working from you. Why I'm telling you this? I'm sure there's lots of people here from home office right now. So
Yes,
you have some 8 hours to. I mean, you need to give to the office, but you steal your time from that
of
and you
course.
focus on your learning here. So that's
Yeah, definitely. These
yeah,
2 hours I work on more. Yeah.
yes. So that's a priority you have given to this workshop. That is what I want to say, right? So make best use of it. Make best use of it. All right. So let's again, Dr. Parmar sir, you there, sir?
Yes, sir.
Okay, sir. We are waiting eagerly for you, sir. We can start the session, sir.
Yes, sir. Yes, sir. Of course.
Okay, okay. Over to you, sir. Over to you.
Thanks, Mukherjee.
Thank you very much.
Welcome, everyone. Uh, let's continue the session where we uh, leave it yesterday. Uh, we have studied about classifications of the data, and we have seen only the two classification, one according to work and second according to nature. And today we are going to learn about the classifications of the data according to function, which we apply in R. So I just share my screen with you. Just a moment. I'll just change the size of this. So we have our third classifications of data, what we are going to start now. And just a moment, just check whether this is working or not. Okay. So that is the third classification we are going to start today. Or am I audible to all properly? Okay. So according to function, we see according to function. This classification we use in R and Python basically. And here we have a first, which is numeric. We have a numeric type data. And also we have integer class, numeric class, integer class data we have. And we have double also. Okay. these data types we find in R. Okay, so these are all same. When we find the data is numeric, data is integer, data is double, I will explain what is the difference between double and integer. Double and numeric are the same thing, because the sum of the packages we use in R, it explain numeric as double. Okay, it shows it's double, but numeric and double both are the same thing. And the numeric means whatever the data, whatever the real number we are getting, either it may be 2.57 or it may be any integer minus plus, and it may be any square root or whatever. So that is a numeric, basically all the real numbers, and that is also double. Okay, the same thing, numeric and double are the same thing. Integer, you already know that -3, -2, -1, 0, 1, 2, 3, and so on, these are all integers. So with this sort of data, we could apply arithmetical operation here, no? If this class we obtain in some data. Second data type is a character. Character data. In the character data, we get we write anything in the strings, and it may be double quote or it may be single quote. Like I write India, so it is our character. If I write any number under quotes, it is a character now. It is not a numeric. So we could not apply arithmetical operation when we have a number in a quotes. So that is we see. And here it is character, but in Python, if we see, it is called strings in Python. And third data type is logical in R, but in Python it is Boolean. Okay, so logical it is a conditional. It responds as in a true and false only. Okay, it is true and false. Two responses we get here always. Then there is raw and complex that we won't have to study. So I'm not explaining about that. These are some mathematical concepts and the IT concepts. We will not discuss on this. So we have these three in the data analytics part: numeric, character, and logical. Okay, these we have to study. And now the second part, we start with the measure of central tendency. We have seen about the classifications of the data. Now we see measure of central tendency. So can somebody explain me what does it mean by the central tendency of the data? Yeah. Mean mode median is correct. How the data is spread, that is a dispersion basically. Okay, and the mean mode median is correct.
Central tendency represents the center point or typical value of a data set.
Correct. This is also measure of the data tend to concentrate. Correct. Middle value. Okay, that's right. Because we could not take our data everywhere. If you have the lots of data, you could not present your data in your research paper anywhere. So we require some value which represent the whole data. So that value is called central tendency. Just we select the member of parliament which represent our constituency in the parliament. Okay, so similar way, we select one value, and there is some method by which we could select that value. Okay, so the value will represent our data anywhere, wherever we want. So that are the center tendency. And if we see, the first one is mean. Second, we have median. Third, we have mode. Mostly we use these three. And if we see about mean, it is an aggregate measure. Aggregate measure means it involves all the values in the data set, and then we could find out the mean. So every value has its importance when we find out the mean. But in median, we arrange the data in ascending or descending order. Then we divide it in two parts. From middle, 50% above that and the 50% below that. So the middlemost value is called median. So it is a partition measure basically. Okay, is it clear? And mode is when we have the highest frequency, and the value of data possessing highest frequency is called the mode. So that is the frequency measure. Mode is a frequency measure. It is based on the frequency. I think someone's please you mute yourself. Please you mute yourself. Most of you have. Okay. Please you mute yourself. So frequency measure. Got it? So there are different natures. The aggregate measure, it is a partition measure, it is a frequency measure. We won't go in the formulae. Okay. Just I write one small data, 2, 9, 13, 25.
Excuse me, sir.
Yes.
Sir, in case of mean, what we generally understood about that is arithmetic mean, but there is another two types, that is geometric and
geometric and harmonic. Correct.
So please state about something.
So here we use the arithmetic mean. Why we don't use the geometric and harmonic, I explain you. Suppose we have these two values, or you have to find out the geometric mean of these two values. So there is a formula, square root of 2 into 9. Does that make sense to you? It is geometric mean.
Yes, sir. Yeah.
And if we have to find out the geometric mean of 3 quantity, then it will be the third root, 2 into 9 into 13. What it? So
yes,
whatever the number of values, you have to take that root. The problem is this is not a problem. So you are taking that root. The problem is that if somewhere we have a 0, then the geometric mean would be
0.
So we could not consider it.
Okay.
First thing. Similar thing in the harmonic mean. If we have a 0, so what we do? We write in this way in the harmonic mean when we find it out. What it? This is the process we have. And 1 by 0, what will happen?
Infinity.
So we could not consider this also.
Okay, sir. Okay. Thank you, sir. Okay.
So I rough this. I just take, so it would be better. And I remove this all together. And this also is not useful for me. And this also. Okay. Let's continue. Here you see this. I have written the data in a ascending order, है ना? In a sequence. So not a sequence, in ascending order. So it is my minimum value and this is my maximum value. Understand? This minimum and maximum value basically are called extremes. Of the data. Suppose we have found out the mean of this data, or we have find out the mean something x is the mean of this data, x bar. I am not writing the exact value. If I change this extreme values, instead of 2, if I write 7 or 5, something else below 9, or I change the value of 49, upper side of the 49, if I write the 51 and the 60 or whatever, the mean will change or remain same?
It would change, Doctor.
It will change.
Mean will change, correct?
Sure. Yeah, sure.
So it means that the mean is very, very sensitive to extremes. Mean is
It's affected by the extreme
sensitive
value.
to extremes. I will explain you later why we are considering, why we are studying this particular thing, the why it is sensitive to extremes, why we are why I have used this thing here. Okay, I will explain later on. So mean is very sensitive to extremes. Understand? But you see here, I write one more number. I write one more number here, which is there are 1, 2, 3, 4, 5, 6. I write one number 51 again. Okay, so we understand that if we change any value in the extreme, if we change the value of extreme, the mean will change, or it is very sensitive to extremes in the mean perspective. Here in this data,
hello,
what is the median of this data? Median is the value of middlemost term.
please, I have a question.
Yeah, 25 is the median.
25 is the median.
25 is the median, correct. So it is our median. If I change this value, instead of 2, I put 7, or instead of 51, I put something more than 51, the median will change or remain same?
It remains the same.
Median
It will
will
remain
change.
same, Doctor.
It will remain same?
No, it will remain same.
No.
So
it will change.
Median will remain the same.
median will remain same, no? Median will not change. I am just changing the value. I am just changing the value. I am not increasing the number.
Oh, I see. Yes. It will remain same.
Understand? I am just changing the value. I am changing from, instead of 2, I am taking 7 or maybe 1 or maybe 0.
Okay.
And I could take instead of 2. Here also, instead of 51, I could take that up to above 49, I could take any value. And the above 51 also, I could choose any value, not less than 49 or that. So that is I am changing the extreme value. Is it clear? So if I am changing the extreme value, the median will not change. It will remain same, correct? What do you say?
Yes, Doctor.
Yes, sir.
So
Yes, sir.
I mean to say that median is not sensitive to extremes. Understand? It is not sensitive to extremes. Similarly, mod is also not sensitive to extremes because it is the value of highest frequency. One more thing I explain, then I will tell you about why I have chosen this one. Okay. In every data or every variable, you will get always unique mean. You will not get two mean of a data. Can we get the two mean of a data? We get the single mean only. If you find out the mean of this
We
data,
can have.
we get only one mean. or we
No,
could get
we
the
can
two
have
mean.
more.
One mean we get. Okay.
Yes, sir.
So it would be always unique. Understand? And similarly, the median would always be unique. But mode may be more than one. Suppose you have a highest frequency, we have these categories A, B, C, D, E. And we have the frequencies of this. A has 12 and the B has 10 and the C has 9 and the D has 12 and 3. So the highest frequency we have 2. Here also and here also. Understand? So we have 2 mode, A and D. Understand? Does that make sense to everyone?
Yes, sir.
Yes.
So we have 2 modes. So it may be more than one mode. It is not that there is a unique mode. It may be more than one. Understand? More than one. So it is the bimodal. There are 2 mode. It may be trimodal if there are 3 mode. Understand? What it? Now,
Yes, sir.
I explain you this thing, why we are studying this sensitiveness. Sensitiveness of the center tendency towards extremes. Whenever we get some data, sometimes we found some outliers. Okay. What is outliers? Some of you may already know about the outliers. Can somebody tell me
These
what
are
is?
high or extremely low values in a data set.
It's not only the extreme values. It is the
Outliers are
values.
data which are
Yeah.
outliers are data which are outside the normal measure of the data, which
Yeah.
go beyond the statistics of the data.
Yeah, correct. You are correct. The values which are very different from the normal data range. Okay, suppose in this workshop, if I ask you, the participants who are attending this workshop, what should be the age range? Hypothetically, you respond. What should be the age range?
25 until 50, maybe. Because most likely it is regarding the research and statistics.
Now you see the persons you have seen here, because you are in the workshop and you have seen the faces of the person. What should be the range? Now, hypothetically, I'm asking. I'm not. It should be 18 to 60, 65, around that. What? It may be at the most 60. Okay.
Most likely like this, doctor. Maybe 50, 55, something like that.
Suppose we hypothetically say that the range of the age of the participants in this workshop is 18 to 60. Correct? The one person whose age is 82 years is also participating in this workshop. Got it? So this 82 years participant is an outlier for this data. Understand?
Yes, doctor. Just to clarify, is it an odd value, doctor?
If the value is, it is a very different value. Most of the participants are under the range 18 to 60, but the one participant or the two participants are more than this range. So they may be the outliers for our data. How to get the critical point for the outliers, I will explain you later on that thing. We have a formula by which we could find out where is the critical point for the outlier. Okay.
Interquartile range, I think so.
That I will explain you later on. Okay. That I will explain you later on. But here we are just hypothetically
Yes, sir.
Understanding the outliers. Okay, there is some measurement by which we could find out the outliers. Okay, that is a different thing. I will explain later on that. So these outliers, whenever we get this sort of outliers, so what we do, suppose this is our scale, this is our 18 years and this is our 60 years, and here is some 82 years person is here. So what we do, whenever we get the data, first we see the structure of the data. What is the structure of the data? In the structure of the data, we see how many observations are there, how many variables are there, and the class of the variables, see which one is the categorical character, which one is the numeric, and this we all see. And then we perform the univariate analysis for each column. Okay, how many missing values are there? We inspect the data and we see how many outliers are. We calculate the outlier critical point and then we adjust that outliers. Or sometimes we remove the observations having outliers. Or sometimes we use some business logic to impute the values for the outliers. So that are the things that we discuss later on. But here the one thing what we do mostly with the outliers, if we have these outliers, so we substitute, instead of 82 we substitute 60, which is our critical limit. Above 60, whatever the values are called outliers. Hypothetically we are assuming that. So the 82 we substitute here 60, so it will come here. If I put 60, is it clear to all? And that moment,
can you just repeat again? Can you
okay,
just repeat again, please?
We are doing the caping. This process is called the caping. Okay, so we are substitute, instead of 82 we are substitute 60. Is it clear? We are inputting 60 instead of 82. So when we input the 60, then it will go here or not? Is there any doubt?
If 82 becomes 60, then it will go inside the
yeah
our
yeah it
our
is
sample.
our
But
sample.
if it was 82, it will be out.
Yeah, correct. If you include this 82, the result will mislead you, your analysis. So we are doing this thing. So first, when you have done the univariate analysis, initially you have done the univariate analysis, you have already find out the mean of this whole data, including 82 and the first moment. Understand? And you have noted that mean somewhere. But when you have input this value, when you have input this value, and the mean will change. The mean will change or not?
Yes, of course. Always the mean is sensitive, so it will be changed.
So it will change, mean will change. So we have to consider the new mean. We have to find out the new mean again. This is very important.
Okay. What is the difference between univariate and multivariate?
Univariate is the study of single variable. We have to study for the single variable. We have to understand the behavior of the variables. If there are 8 members in your family, every member has a different nature and behavior. Understand?
Okay.
In any family. So if we have in the data frame so many variables in our data frame, so every variable has a different nature and the different variables. Suppose we have a age, one variable, and income, another variable. Understand?
Okay.
So age we will get only the 2-digit form, 32, 85 in this way. But income we will get in the 5-digit or the 6-digit. Understand?
Okay.
That is the thing. Or this may be the age may be the new normal distribution in the age. If we see the histogram of age, we see it represents the normal distribution. It adopt normal distribution. But the income, if you see, so there is some skewed. It is not a normal distribution.
Yeah.
Understand? So
that
we
means, doctor, in univariate we study each variable alone.
each variable alone, individually,
That
each
means suppose
variable
that
individually.
if I do have 3 independent variables and 1 dependent variable and 1 moderator, in this case I need to study the variables 5. I need to have 5 univariate, so the 3 independent, 3 univariate to find out the relationship. Then 1 for the moderate and 1 for the dependent. Is this correct?
Yeah, we have to, the univariate means we have to individually study the each variable separately, and then we, if we have to find out the relation between some variables, then we use the bivariate, or then we use the further we use
Multivariate.
the multivariate also.
Multivariate to find out the relationship between 2 variables, doctor?
Multivariate, we see the impact of a variable,
Multiple variables, I think.
impact of multiple variable on a particular variable, on a dependent variable. That is the regression. Basically, we do the regression analysis here. Understand?
That's regression analysis.
And here we do the correlation analysis in the bivariate. Got it, sir? In the univariate analysis, what we do, we find out the mean, they find out the dispersion, that is the standard deviation or whatever, the mean, mode, median. It depends. Mean, median, mode, and the standard deviation, IQR, whatever. And also the shape of the data. In the shape of the data, we see the figure of the data. We create a histogram or the box.
Hello,
plot.
sir.
Yeah.
Sir, in multivariate, we are doing regression analysis. We are doing linear regression.
Hey, we could do the logistic also as well.
Okay, sir.
We could do the logistic. It depends. Then we convert them. We use some cutoff point, and as per we decide whether it is yes or no.
Okay, sir. Okay, sir.
The logistic. So we will read this whole thing in the advanced part. All this sort of the regression and the up to correlation we will cover here in this workshop, and the regression we will see in the one advanced part. Okay. So understand what does it mean, sensitiveness. If you are dealing with the outlier and you are you have a normal data, generally the normal data we believe on the mean. But if your data is skewed like this, it is positive skewed, then we rely on median instead of mean. Understand? And then we have a different formula to find out the critical limit of outliers for the skewed data. For the normal data, we have a different formula, and for the skewed data, we have a different formula. This we read later on in this workshop. It is not here, but in this workshop, we will, when we perform the descriptive analysis, in the descriptive analysis, we study about the univariate and the bivariate analysis. Understand? So then I will explain you this thing in the depth. So up to now, it's okay. So why we use this? What is the importance of the mean? Because to understand the behavior of the variable, it is very compulsory to study about the central tendency first. Okay. Second thing, for understanding the behavior of the variable, we have to study about the dispersion, measure of dispersion. We write here. What it? Measure of dispersion. Can somebody explain me what does it mean by the dispersion in the one word? What does it mean, dispersion? Yeah. Variability, correct. It shows the variability, correct. Spread, correct. Correct. Range is also a measurement. Deviation is correct. Scattered, correct. So two things I explain you here. One is the spread and the other is a scatteredness. And spreadness and scatteredness. I just take one example here. There are two things in the dispersion. One is the spreadness and second is the scatteredness. Spreadness is basically overall and scatteredness is within. I explain you how. So I write here 2, 7, 11, 15, 23, 42. If I talk about the spreadness, spreadness is overall, and how your data is spread. So that is basically the maximum minus minimum. That is range. Okay. Or here we get 42 minus 2, which is 40 is our it is the range or it is the spreadness, basically we could say it. Does that make sense to everyone? But if I talk about the scatteredness, okay, so we see the difference between these two consecutive data points, which is 5. Difference between this consecutive is 4. Is 23 minus 15. So it is 8. What it? And here we see 12 minus 3 is 9 and 3 minus 2 is 1, 9. So now you got what is scatteredness? I have written that the within. This is the scatteredness of the data. How far the each data point to nearest data point. Okay. We could find out the average scatteredness. Average scatteredness we could find out. We add on these all differences and we divide by how many? 1, 2, 3, 4, 5. Divide by 5. So whatever the value we get, that is a average scatteredness. Okay. So first we talk about the spreadness and then we talk of the measurement of scatteredness. You see the range is the measurement of spreadness. Interquartile range is also the measurement of spreadness. These are all the spreadness. And semi-interquartile range or the quartile deviation is also a measure of spreadness. But mean absolute deviation, standard deviation are the measurement of scatteredness. Understand? In the scatteredness, we involve all the points. We involve all the, here you see we involve all the points in the simple scatteredness. But in the mean deviation, mean absolute deviation or the standard deviation, we also involve all the points. But in the spreadness, we involve only 2 points, as you have seen in the maximum minus minimum. We're not involving all the points. Does that make sense to you? Yeah, Manmeet. This in the range is a measure of spreadness. So first measurement of the dispersion, which is a measure of spreadness, is the range. Or range is nothing, it is the maximum minus minimum. I just tell you this thing. And if I give one more example for this, so just a moment, I just take one line from here. and I draw this line. I want to draw this line here, and I want to use color black for this line. And now I put some points over here, and I use this. So this is my 0, and then it is 2, it is 4, it is 6, it is 8, it is 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. Does that make sense to everyone? Okay. So this is our, we have data scale. And what I am going to do here, I am selecting 2 data sets from this population. This is my population. I am selecting some data sets from here. One data set I am getting from here to here. That is my A data set. And one data set I am getting from here to here. That is my B data set. And I find out the range of A and the range of B. What would be the range of A? 8. And what would be the range of B? It's also 8. If I give you the range of the data only, I say only the range of A is 8 and the range of B is also 8. Can you go to some conclusion? Can you analyze it through this? Only the I have given you the data, the range. Can you go to some conclusion if I say the A and B data set has range 8? You could not do anything. You could not analyze it. You could not go to any conclusion. Correct, Sajjad? So at that moment, because why we are not going to get anything from this figure? Because a range is a absolute measure. It is a absolute measure. If we have to find out something out of this, then we have a requirement of relative measure. What sort of measure we require? A relative measure. So how we get, what is the relative measure of for range? So whatever the coefficients we take, they are called relative measure. And as you see the correlation analysis. In the correlation analysis, we perform the correlation between 2 variables, not only with the one. So there is some relation. We see the relation between X and Y. So we find out the coefficient of correlation. We could not find out the correlation between 2 variables. We measure the coefficient. We measure the coefficient of Karl-Pearson coefficient of correlation. We measure the Dispersion rank correlation coefficient. We measure the Kendall's correlation coefficient. We don't say that the correlation. Does that make sense to everyone? Because it is a relative measure. Does that make sense to everyone? So in the relative measure, we use the coefficient of range. So how we get the coefficient of range? So it is a maximum minus minimum over maximum plus minimum. It will provide us the relative measure. Now we see how. We see the, I change the color. Coefficient of range of A would be 8 over 10 plus 2, 12. So it is 2 by 3 or it may be 0.67. Got it? And if I see the coefficient of range of B, that is 8 over 20 plus 28, it is 48. It is 1 over 8, 1 over 8, 1 over 6, or it is 0.167, like something. Does that make sense to everyone? Now I put this coefficient of correlation here and this correlation coefficient here. Now you see, now you conclude if I give you the coefficient of correlation of some data. Now you could go to some conclusion or not. Can you conclude something if I give you the coefficient of correlation instead of coefficient of range? What we may conclude? Can explain? You see the data and you see the coefficient of range, then you could make some relation between data points and the coefficient of range. It will tell us so many things. Can somebody say me something about it? Yeah.
Correlation coefficient means there is an aggregate value, which is a combination of entire data points.
Correct. But how do you conclude this? Renuka, you are right. When we are going towards right hand side, the CR tends to fall. It means if you have the coefficient of range is higher side, if the high value you are getting in the CR, coefficient of range, it means your data is from low value data points, belongs to low value data points. If your coefficient of range is low, like 0.167, it means your data belongs to high value data. Shraddha, you have not got it? You see here we are getting the 0.67, okay, and we have the low value data 2 to 10. If you go towards right and we see the range is same, but the coefficient of range is now 1.167 and this is the high value data. If
Got it, sir. Got it.
Got it, no?
Yes, sir.
So when you go towards right, the coefficient of range will decrease. The value of data will increase. So if I give one option, suppose there are two companies A and B. Suppose X and Y, we have two companies, and both offer you job. They give you the offer letter, and in offer letter they have mentioned the coefficient of range of their employee salary. Understand? They have mentioned the coefficient of range of their employee salary, and you have to select one. So I'm writing their coefficient of range of employee salary 0.67 and 0.35. Which company you will select? Other things are same in both the companies.
0.35.
Okay, so Y company we will select. We will not select the X1 because the X1, the coefficient of range is higher side. It means the salaries would be lower than Y company's salary. Understand? Does that make sense to everyone now? Emmanuel, have you got it now or not? Emmanuel, you asked me, please you kindly say again. Now I think you understand. So the coefficients plays very important role in statistics also. It's also, we see the coefficients not yet. Okay. You see, first you see the formula is the maximum minus minimum or the maximum plus minimum. So we have calculated this. You got this calculation or not? How we get these values? Okay. So you got it. And I have written this coefficient of range here on the both data set. So here you see, if we have the higher coefficient of range, the data values are very low, 2 to 10. And 2, 4, 6, 8, 10. The data values, this belongs, A belongs to small value data, low value data, we could say that. Or here we are getting the high value data, but having the low coefficient of range. Understand? No? Always high value data possess low coefficient of range. Now you got it or not? Okay. So it also plays very important role, coefficient of range. Sometimes we got some statistics only. And we somebody asked us what is the main thing in the statistics, what I have explained yesterday, the interpretation. Interpretation means what? Understanding of the data, what the data is telling to you. Understand? So that's why we should know all statistics. What does it explain to us? We should know. So the coefficient of range and the range explain us in that way. Okay. Now we see the second measurement. Please you mute yourself. Someone's mic is open. Please you mute yourself. If you have to ask something, then you unmute yourself. Otherwise, you keep it mute. Okay. So now we see just a moment. I put it here and I could use this. Now what I do, this is our data set. This is our minimum value. I change the color so you could better understand it. Sebastian, please you mute your mic. It is our maximum value. And in between it is our median. Median divides the data in two parts, 50-50%. Got it? And there is 2 points we are again taking. This is our Q1, first quartile. And this is our Q3, third quartile. So what does it do? It is that there is 25% and there is 25% of the data. There is 25% data and there is 25% data. Got it? So between Q1 and Q3, we have 50% of data. Understand? Because 25% is here and 25% here. So we have remaining only 50% data. So sometimes what we do, second measurement, what we are going to use is the interquartile range. Interquartile range is Q3 minus Q1. Okay, that is the interquartile range. These 2 points we find out the first quartile and the third quartile, then we see the difference of this. That is the interquartile range. And here the coefficient of interquartile range, it is called the IQR basically, interquartile range. It is Q3 minus Q1 upon Q3 plus Q1, the same thing. Okay. where we use this, that is very important. This portion is called whisker. This also whisker. When we create a box plot and we see this height is very compact, Q1 and Q3 height. This width has no importance, only the height is important. And this whisker length is higher. This whisker length is also higher than this portion. This height, this is greater and this is greater. Means where most of the data lies between Q3 and Q1. And if you include this, you use a range, then range will mislead you. Range is the maximum minus minimum. The range will mislead you. Then what spreadness measure you will consider? At that moment, you will consider the spreadness measure interquartile range, where the data is very dense in between. The points are very near to each other, 50% data. Does that make sense to everyone? Okay. Now, next measure is our semi-interquartile range. Semi-interquartile range is nothing, it is just 25% of the data. We get only this much data only. I changed the color so we could get it better. Only the 25% data here to here. Very dense data. That is semi-interquartile range. Okay. And the coefficient of this also the same. Semi-interquartile range is also called the quartile deviation. Quartile deviation. Okay. And this coefficient of quartile deviation is Q3 minus Q1 over 2 over Q3 plus Q1 over 2. So 2 and 2 will remain. It will eliminate to each other. So we get the same coefficient as we have got what the IQR. The coefficient of IQR and the quartile deviation are same. Does that make sense to everyone? This is same to this. Got it? Is there any doubt?
Yes, sir.
You know that in the COVID-19 test, 90% tests were false positive. WHO says it. Now they are accepting this thing, and I told this before many days, this test is not viable. Whatever the test they are using, I claimed only the 60%, but recently WHO declared that the 90% test, whatever they are taking, the false positive test. It is not the true positive. If the test they are telling that the 100% you are positive with COVID, out of 190 are not positive, but the test is telling they are positive. So in this sort of study, when we perform this sort of test, we make the slide, and whatever they do, there is a, for at that moment, there is a requirement of quartile deviation. We have to work on the very dense data. If you are working on the whole data, whatever their features, it depends on that. If you are working on the whole range, there is possibility of the false positive in the laboratory science. Mostly work has been done of the culture and this all things on the quartile deviation basis. Understand? So guideline wise was not clear. For performing this test, what you have to do, you have to use the quartile deviation or whatever the results you are getting. The thing is that the laboratory things. So they have not applied that thing and they have fixed the parameter. During fixing the parameter, they perform some analysis, and then those parameters, those guidelines, they provide to the further work. So quartile deviation, we take this 50% only the concept. So when they generate some test for the COVID-19, so they had to work on the quartile deviation, not for the whole data sets. Whatever the values they are getting, that is a very deep thing. I could not explain the whole thing here in this one session. And as per that, they have to declare the set the norms and the whatever the thing. So that is there is some mistake. Okay. So this is the quartile deviation, and we have seen the coefficient of quartile deviation also. And now we talk about the scatterness. Here I am using some data points, so I could explain you. Hypothetically, we are making it for visualization for better understanding. Okay. Practically, the data points not take this form, but for the better understanding, I am giving this. So there is our this data point is x1. This is our x2. This is our x3. This is our x4, x5. Please you mute yourself. Afroz, please you mute. And here is our mean, and here is our median, and somewhere is our mode also. And we have n data sets. So it is our xn, suppose it is xn minus 1. In this way, all data points have some number. Does that make sense to everyone? Now, what we are going to do, we are going to find out the deviation of each point from the central tendency. Now, we are going to find out the deviation of each point from the central tendency. First, we are considering the mean as a central tendency. Later on, we will work with the median and the mode also. So I am going to find out the deviation from mean of all points. So I will get the deviation in this way, the distance between, and then distance between. Getting it or not? All points. I will not draw the all deviations. I am drawing very few. Okay. For the all points, we will get. Okay. We get these all deviations. Is it clear to all? Manisha, Are you getting it or not? We are getting the deviation of this mean, the deviation of all data points from the mean. How far they are from the mean. Does that make sense to you? Now, what we do, we find out this deviation xi minus x bar. I is from 1 to n. X1 to x bar. And if you get the summation of this only, you always get 0 because you are getting the deviation from actual mean. Does that make sense to you?
Yes, sir.
We get the 0 always. You take one small data set and find out the mean, and then you get the all data points deviation through mean, and you get the summation, you will get the 0. Okay, somebody has some confusion. Okay, small data sets, 5 data points, 10 data points, whatever. So it will be 0. So what we could, they have done, they have taken the absolute value of this deviation. So wherever we have the negative values, it will convert in positive, because here the some values are positive and the some are the negative. And if we get the summation of the negative and positive, we get the 0. Okay. But here we are getting the absolute value. We are converting the negative value into positive, and the positive will remain positive only. So we get some value here. Some positive value we will get or not. If we get the summation of this, we get some positive value. And finally we divide it by n. So it is the deviation, summation of the deviation dividing by n. It means it is the deviation of mean. Sorry, it is the mean of deviation. It is the mean of deviation. Is it clear? It is mean of deviation. Does that make sense to everyone? But not only the deviation, it is mean of absolute deviation. We have taken the absolute value. Got it? So it is called mean absolute deviation. In the short, we say, we don't use this preposition and conjunction, this all. So mean absolute deviation. Got it? And it is right in this way, made. Mean of absolute deviation. And this mean of absolute deviation, because we have taken this deviation through mean, so it is called delta x bar. Similarly, we could take the deviation through median also instead of mean. It is called the delta ME. Similarly, we could take it from the mode. Does that make sense to everyone? Okay. If I write somewhere, MAD is 22. Can you say me from which center tendency I have taken the deviation? If I just write the MAD, can you guess whether I have taken from the mean the deviation I have taken from the median or the mode? Sally Sparta, how could you say that I have taken this 22 through the mean? This deviation, mean absolute deviation, is through the mean. Because we could consider all the center tendency, we could take the through median also and the through mode also. If I just write the 22 MAD, what does it mean? Mean absolute deviation 22. So through which central tendency I have taken the deviation? Can you say me? Can you guess it?
Sir, hello?
Yeah, Shelly.
So actually in starting when you said that we are taking the summation from the mean and that is called as mean absolute deviation. So
No.
okay.
Mean of deviation.
Okay.
Mean of absolute deviation, or we
Yeah.
give it name mean absolute deviation.
Yeah.
We have given this whole thing. We said that the mean absolute deviation, that is a made, or it can be taken through the mean, taken through the median, or taken through the mode. And
Yeah.
all we say the mean of absolute deviation. This is the absolute deviation through median.
Yeah.
Next one is the absolute deviation through mode. But all the we are getting the mean of all.
Okay.
So if I just write the MAD and I put some value 22, so can you guess from which central tendency I have taken the deviation?
No, sir.
We could not say. So there are few demerits here in this mean absolute deviation. So I explain you one by one. First demerit was there is no specific central tendency. Okay, understand? For taking the deviation, there are three central tendency you could take the mean absolute deviation. So that is not, there is no specific. Second thing, arithmetically it is okay, you are converting negative into positive, absolute value you are taking, but algebraically it is not correct. So algebraically taking absolute value is wrong. We are taking absolute value, or algebraically we are writing this form. Understand? It is wrong. Third thing, it is unidirectional. These three demerits in this mean absolute deviation. Unidirectional mean you have seen the pendulum. It deviates in both the direction, not only one direction. The same distance. What it? So here you get always the positive value. And suppose you have a mean of three companies, salary of the employees of the three companies, mean salary of the employees of three companies, XYZ. And this is the mean salary. It is the, suppose 45,000, it is 62,000, it is 51,000 mean salary. And there is a deviation. If we mean absolute deviation we take, it would be only in the positive direction. It will not only the here downward. If there is a 7,000 hour mean absolute deviation, then it would be on the upper side. Here also, if we have 9,000, if we have 2,000, it is only unidirectional. It is not in the both direction. Understand? It is a one directional. What it? Because we are getting the positive value only, no? So we will add on the whatever the mean we have taken, we will add the mean absolute deviation on the one direction. We will add only it. We could not subtract it from the mean. Can we subtract it? Because we have the positive value only. Does that make sense to everyone? Now, they have removed these three demerits. They have worked on it. And they have used a standard form, and this is a standard deviation. They have given a name standard deviation. I change the color. First demerit they have used, the deviation will be taken through the mean only. They have fixed it. It is the standardized. The deviation will be taken always with mean, not median or more. Second thing, for making negative to positive, they are using that if -2, if I take the square of -2, I will get 4. If I take the square of 2 is also 4. So they are taking the square of deviation. Instead of absolute value, they are using a square of deviation, which is algebraically right. And they are taking the mean of a square of deviation. What they are doing in this way, xi minus x bar square, and then they are getting the summation and then dividing it by n. So that is the deviation. That is the mean of a square of deviation. So then they finally square root it. And when they square root it, so we get the negative and positive both. What it? So it is bidirectional now. Now it will work in the both direction, downward also. What it? Is there any doubt? Does that make sense to everyone? So this is the standard deviation. Somebody asked me on the chat box that where we use the MAD. We use the MAD when our data is skewed. I will explain you later where we have to use the median, where we have to use the mean. So I will explain you when we have to rely on mean or when we have to rely on median and don't rely on mean. Okay, that is very important. Without understanding the data, you could not do the analytics. Okay. So whenever we have the skewed data, we will use the MAD. And in R, MAD is always calculated with median. So whenever you will get the MAD, it will be the deviation taken through the median. Okay. Then we use MAD only. MAD with median. Okay. If your data is normal, then you use standard deviation. Now I tell you some more thing. There is then variance. Variance is nothing, it is the square of standard deviation. If you take the square of, if you remove this square root sign, then it is a variance. And there is a coefficient of SD, that is sigma over x bar. And if we see the coefficient of variance, it is sigma over x bar. Both we are taking the sigma over x bar, the same thing, but it is multiplied by 100 or the 100%. Suppose we have a skewed data, it may be positive skewed or it may be negative skewed data. Whenever we have this sort of data, we rely on the median instead of mean. Okay, understand? We consider the group median. We don't consider the mean as a central tendency. And that moment, we use MAD, mean absolute deviation, through median. Understand? Is there any doubt now? If your data is normal, then you have to go for the group mean, and you will use the standard deviation. Understand this thing? Apilam, Apum, have you got it now? Okay, I will explain you this thing in detail also in this workshop. The later on, the tomorrow or the day after tomorrow, we have these all things. Don't worry. All the concept would be clear. You know that there are so many courses are running, just like free courses, everything, every company, the Google and the every company, they are providing, but they are not providing the concepts, what works behind. They are just providing what is machine learning. They are providing the algorithm script and the everything. You will get so many, but you don't know how to start, from where to start. That's very important. Okay. These concepts are very, very essential. You download the video, what I have given you the link, and it will always be beneficial for you. Okay. And the whatever the PPT I have prepared, that is also very, very beneficial for you. It will be the assets for you for the long time. Okay. Now, I have explained you this about the variance and this. So, what is the use of coefficient of variance? Through the variance, you could see the variability, how the variability of the data. But if somebody asks you, find out the consistency of the data, find out the stability of the data, then you have to consider the coefficient of variance. You don't do only the variance. You have to find out the coefficient of variance for the consistency. If you have to find out the consistency of the data, if the coefficient of variance is low, your data is more consistent, more stable. Does that make sense to you? Whenever you have been asked, you may ask for find out the consistency of the data, you find out the coefficient of variance, not on the basis of variance on the basis of standard deviation. You don't say that thing, it would be wrong. You find out the coefficient of variance and put that value. Okay. Okay, every data should have some variance. If data has no variance, then that variable is not usable. Understand? So the variability is very, very important. If your data is more consistent, then you could not find out the new things in the data. Okay. You could not find out the new information from the data if data has no variability or less variability. If the data is high variability, then it will give you the more information or not. I will explain you that thing, Aisha Ahmed, about the how we get the skewness and this through the R. From tomorrow we will start this all thing with the practical with R. Okay, today up to today we have the theoretical part. Tomorrow we will start with R. Okay. more thing I would like to explain you. For the coefficient of this also I will tell you. Coefficient of delta x bar over x bar and delta me over me and delta z over z. These are the coefficients of the mean absolute deviation through mean, mean absolute deviation through median, and mean absolute deviation through mode. Understand? These are the coefficients. We have to divide that mean absolute deviation through that central tendency. No? Same central tendency, we have to divide it. So that is the coefficient. So I think, is it clear? Everything has been clear to you? Is there any doubt? No? Okay. So now I explain you how to download R programming in R Studio in your laptop or the system, whatever you are using. Okay. How many do you have the laptop or the system, whatever you could work on that? How many of you? How many of you have the system on the laptop? I think most of you already. Okay. Without it, you could not do this study. So we will, how we download it, I explain you. We just open the Google search and we just write down download R programming. First you have to download the R programming and you will get the cran.r-project.org. Okay, and you click here. If you have window, then 4.0.3 is for window. If you don't have window, you just do it. You will get here for the Linux and for the Mac. Understand? Is there any doubt? First you download it and you run it. It will install in your system. Don't change the path. It should be in the C drive, wherever it will take, it will go by default. Don't change the path. And after installing it, you download R Studio. So I explained you how to install for the Linux. Shraddha. That's very simple. Just to R Studio download. What you do, go here. Most of you have already 64-bit. So we have to use the 64-bit mostly. And if someone has the 32-bit, then he may shift to 32-bit. The R desktop, you see here 4 options: R Desktop Pro, R Studio Server, and R Studio Server Pro. So we have to go for the desktop free, and I will click on the download. So I will get here for Windows. For other, you could search. There are the for Studio Ubuntu 1.6, Fedora, Debian, and so you could take it from here. So we will click here. It will be downloaded, and then if you have the 64-bit, if you have 32-bit, so I will explain you where you will get that older version. For the 32-bit, you will get here the all installers. Okay, so you download it and install it. When you install it, then you will get, this is the symbol you see where my cursor is. It is the R programming, or this is R Studio. So we have to work with R Studio. R Studio basically R programming and R Studio, I explain you. R programming is a graphical user interface. The every programming language we could operate from the terminal, or we could operate from our command prompt also, and there's some other text editor we could use to operate that. But every programming language gives us some GUI along with it, graphical user interface. And there are a few IDEs, integrated development environment, which is very, very interactive. where we could work very easy way. So that is the IDE. So R Studio is the IDE of R programming. So we could hypothetically we could assume that R programming is the kitchen of the restaurant, and the R Studio is the sitting area of the restaurant where the customer take food, and automatically it will integrate to each other. In the back end, the R program work, and the front end we see in the R Studio. Understand this thing? Then we have to choose the free. You will get all the features in free also. There is no any discrimination with respect to features of the programming. Features of the program. There is no any discrimination with respect to feature of the programming. Okay, that is for the real-time analysis. If some company wants to purchase, they may purchase the commercial one, so their data may be safe in the real-time analysis. They use the commercial version, so they get the login ID, password, everything over there. Nobody could hack their data. Understand? But the features will be same. You will get all the features except that security features. Okay, high level security features. Is there any doubt? No. So you install it. Tomorrow we see if somebody is getting some difficulty, we rectify it tomorrow, and we start with our practical. Only the one thing remains in the theoretical part that I will explain you later on with the univariate analysis and the descriptive analysis, the bivariate analysis, the correlation analysis. That I will explain the theory later on. So yeah, anyone has any theory?
Now, Chief, can we get access to the PowerPoint and the video? Those of us who have not paid for the course.
Okay.
Is there any way of getting the PowerPoint presentation or the video?
So
Just to, this is actually, you have said that the first part of R1 is free.
The first part is the free. Free means we
for
means
the
yeah.
for the PowerPoint and the video.
Okay, it will be
Let's
explained.
know that so that we can get prepared for tomorrow's.
Okay.
Yeah.
So
About
I will take over to you, Mukesh ji, and he will describe you and understand the problem.
Let me send it.
Okay. Mr. Mukesh, are you there? Yes, sir.
Yeah.
Sir, over to you, Mr. I think, and there is something, some problem. I don't know. What is that?
Yeah. You already explained that the first part of R and the second is free, and we're going to get the PowerPoint and the video.
Yeah, I
That's
heard your
possible.
question, Anil. The thing is that if you want to get the study material video link, it is available with the $18 payment, right? You can just pay
18.
$18. You can get that.
118.
1.8, only 1.8.
1.8. So how can we? For me, for example, I would like to pay, but is there any means?
Yeah, just a second. I posted here on the chat box. You can just try to copy that.
We don't have international bank here. I don't know how I can pay
You
you
can
for
do
that.
PayPal. PayPal is the easiest way.
Okay.
1 second.
All right. So that 18, we include the certificate as well, right?
Yeah, that includes certificate, study material, video recording of the session. I just posted for everyone the bank details if they want to get. It is $18 USD for, and or you can convert it in your national currency for
So-
international participant.
So we pay. You have
Those
represented
who
here,
are in
or
India, can pay through Indian bank, which is around 1,000 rupees only.
do you have representative here where I can go and buy? Or I don't have
Where
international card.
exactly you're located in Del?
In Addis, Ethiopia.
Ethiopia.
Yeah.
I'll try to get somebody for you, and he might be able to help you. All right.
All right. Thank you.
Else in Ethiopia, I think PayPal works. But if not, I will try to get somebody for you.
I don't think there's a way
Okay.
for international payment.
Also, you
Okay,
can
let me. Okay.
type my WhatsApp number. You can just contact me there also if you have any. I'll just post in the chat box. Please refer the chat box. All of you copy it.
Okay. Thank you.
Do you have someone in Benin? Just contact on WhatsApp. I'll try to connect with you. In Nepal also we have somebody. Don't worry. We have our people around the world who help you. And those people are from the participants itself. It's not that we are hiring some sales guys or something like that. We are just from people like you who help this organization to grow, So they are like, supporting this organization in some way. So I will connect you that. All right. So all of you are happy with the today's session? Okay, I
Yes.
see there's a lot of down faces. I think, is it too much knowledge today?
So,
It's very
we
nice.
can do it later, right?
Okay, if it is good knowledge, keep smiling. Life has bad days also, that when there is a tough knowledge coming, you have to smile. You can't take that, you cannot complain that sir has taken, that extra knowledge. So you have to keep smiling even you have extra knowledge. So keep smiling. That is the best way. All right. Feel fresh. When you come here, I want to see all of you feel fresh. And when you leave the session, feel fresh. All right. So all of you feel happy, smiling, keep smiling. God bless you, all of you. So we'll meet tomorrow again, 5 o'clock sharp tomorrow. And come on time so that you don't miss the session. All right. And tomorrow, what we can do, we can discuss. I'll take 10 participants to talk 2-3 lines about yourself. First, I will start 5 minutes before this session, around 5, I think 4:45, 55. So we will have 10 participants. I'll choose randomly, and you will talk about yourself, what you do, and how this workshop is helping you. All right. In 2-3 lines, 4 lines, you have to end up. You cannot make a speech like politicians. You have to talk very straight and clear that okay, I enjoyed it, I didn't enjoy it. Okay, if you enjoyed, you'll talk about it. And mainly the reason for that speech is that you will talk about yourself, what you exactly you're doing. You might be helpful to others, like let's say somebody in the biotechnology, somebody is in some industries doing research on something, so you can connect to each other. That is the purpose of that workshop. So you will talk more focus on your things. All right. And at the end, you will talk about how did you find this workshop? Did you like it? You will say yes. If not, you will say no. All right. So let's connect tomorrow, all of you, with the happy and smiley faces around the world. Bye bye.
Thanks, everyone. Okay, bye-bye. Bye.
Thank you.
Okay,
Thank you.
bye. Thanks.
Thank you, sir.
Thank you, sir. Thank you.